Okay, today we're going to look at 3D trigonometry. What we're going to try and do is to try and find right-angled triangles in 3D space and practice doing that so that we can solve problems. First up today is this example. So we have to work with these sort of three-dimensional cuboids and envisage right-angled triangles within them. In our first question, we're after the length of DF. So if we find D, it's there, and then F is up here. So this is the line that goes from it's basically the longest line that you can get in a cuboid. It's from the bottom of one corner up to the top of another corner. No matter how long the lengths are of the different sides, this type of a length is always the longest, and it doesn't matter which corners you go from, you'll still get the same length. E to C will be the same. H to B will be the same. They'll all be the same length. This is the length that you would get if you were to put a long spoon lying into the box. It would lie along there. But the trick to finding the length of this one lies in this triangle in the base. Can you see? I'm going to start off with this triangle in the base here. Oh, doesn't like that. Nope, it's not letting me do it. Nope, we just draw it. Do you see this triangle down here on the base? What are the letters of the vertices for that triangle? I'm going to draw it as a right angle triangle here. What are the letters for the vertices? So we have B, C, and D. What is the length of BD? Sorry, BD we're going to try and find. What is the length of BC? This one's 4. And BC? 5. And this is the one that we're after. So in order to find this particular length, what formula could we use? Yep. So if we write this into Pythagoras, it tells us that x is going to be the square root of, oops, that's not liking that today, 4 squared plus 5 squared. Can we simplify that? Don't simplify it into 3 significant figures. Simplify it to an exact value. All right, so what do we get there? 21? 41, yeah, perfect. Use values like this, particularly because the next step is also going to be another Pythagorean theorem, and you'll square this and the root 41 will just become 41. So now we have to envisage the other triangle. So can we see, I'm not sure which is the best way to draw this. Try it like this. Can we see this triangle here? I'm going for that length, down there, and then across here. This is also going to be a right angled triangle. So this new one I'm drawing, I'm just going to pull it off down here. What are the vertices of this right angled triangle? So which one's at the right angle? B. And then up in the air is F, and I think it makes sense to write it like this, D. That's the right angle triangle. Do we have any lengths?
6 centimeters.
Which one's 6?
FB.
FB is 6. Do we have any other lengths?
41. So
root 41. Which one is that one?
BB.
Yeah, root 41. And this is the length that we're after, isn't it? So let's have a go at calculating that. So y is equal to the square root of, we've got 30, so not do it that way. We do it as 6 squared plus root 41 squared. So, yeah, That's going to be 36 plus 41. What's that going to be? Is it 77? Brilliant. Brilliant. So this is the length of the diagonal, DF. Now it wants us to find the size of this angle, BDF. So BDF is this angle here. It's the one that we've got there in that triangle. This is the angle that we're after, BDF. We could use the cosine rule. I wouldn't recommend it. At this point, we've got the cosine rule, the sine rule, but the trig identities. So always ask yourself the questions. To find the angles, is it a right angle triangle? If it's a right angle triangle, it's SOHCAHTOA and Pythagoras' theorem. So when you're solving a problem, the hard part now is we have so many formulas, you're selecting the right one. The sine rule will work for this, but it's stupid. You'll be doing the sine of 90, which is 1. It disappears and it becomes the trig identity. So ask yourself the questions, is it right angled? If it's right angled, Pythagoras' theorem, SOHCAHTOA. If it's not right angled, then it's sine rule, cosine rule. Start for trying to use the sine rule first. Look to see, do we have a known angle and a known side opposite? We would have that in this problem. We would have, because we know this one now and we know that one. So you could use that as your ratio, but we don't need to, because the sine of 90 will disappear anyway. We can go straight to SOHCAHTOA. So it doesn't matter which one, we've got all of the different sides here. We've found this one to be root 77. What I would generally recommend is, you could use either any of SOHCAHTOA. I would recommend using TOA, because that avoids using the one that we calculated last. If you can avoid using sides that you calculated, you're likely to reduce errors. If you've calculated it, it could be wrong. If they gave you it, it's definitely right. Now, in this case, we calculated 41 first, and then we calculated 77. So if any of them is going to be wrong, if 41's wrong, 77's wrong as well. But if 77's wrong because we made a mistake, 41 could still be right. Which is why I would recommend in this case using this length here and this length here. These are opposite and adjacents. So we're going to want the tan of theta is equal to the opposite over the adjacent, which implies that tan theta equals 6 over root 41 theta. What is the angle? What is the angle of theta here? Yep. Give me that again. 43.1. I'd agree with that. 43.1 degrees.
But you also get the same result if you do the inverse cosine. Yeah.
But using the 77.
Yeah.
The 77 and the 41. Yeah. You will get the same result with all three of them. But what I said was, I'm going to avoid using the 77 because I calculated that one last, meaning there's 2 chances of me making a mistake. In the 41, there's 1 chance of me making a mistake, and in the 6, there's no chance of me having made a mistake. So, but you'll get the same with sine as well if you use 77 and 6. All 3 will give you the same. Okay. Let's have a go at another one. This one's a little bit harder. Have a go at this one for yourself for 5 minutes, and then I'll run through it.
Yeah.
All right, so we need to try and find all 3 sides of the pink triangle. So if we look to begin with to try and find this length here, this diagonal from side to side through the midpoints, MN, that's the same as this length here in this triangle. So we'll start off with that triangle. This triangle has its right angle at C, and then we've got B and D. So BC is 4, this is 5. So this one, using Pythagoras' theorem, is going to be 25 plus 16, 41. This one's going to be root 41. Nice and quick there. Let's go for this one up here. We've got a right angle triangle there, which will give us that side. I'll just draw the right angle triangle. I always like to draw my right angle triangles this way up. Which one is the right angle? It's H. And then we've got M here and E there. E is one of the sides. It must be the same. E must be the same as this one here, isn't it? So E, sorry, when I say E, I mean HE. HE has to be the same as that side. So that one's a 4. Whereas HM, that's half of the 6. So that one's going to be 3. This is a 3, 4, 5 triangle. I've got that one. And we need to find this triangle here. Draw it down there like that. Which one is the right angle? It's F. So we've got our N there. That one's going to be 3 again. And this one is E. So this length here has to be the same as this length here. So it's going to be 5. 5 squared, 25. 9 squared, 3 squared, 9. 25 plus 9. 31. 34. So now we've got the triangle that we're after. And the triangle that we're after is not right angled. No, it's not a triangle. Thank you, iPad. Make this a triangle, you silly machine. No, I'm just going to freestyle it. Okay, so we've got root 41, we've got root 34, and we've got 5, or root 25. Let's get the sides up. So B. So this is equivalent to MN. So if this here is N, this is M, and then this one is E. Yep. We need to find the angle NEM. NEM. We want this angle here. Which rule should we use for this one? Cosine rule. So the cosine of E is going to be, now we've got 5 squared plus root 34 squared, which is 34, minus root 41 squared, which is 41. 2 times 5 times root 34, which implies that E is equal to, what did we get as our answer? 72.0. 72.0 degrees. Okay. Right. Have a go at this as your classwork exercise. This one's a little bit more challenging. This one is a bit tricky here. I'm not going to run through this one. That's it from me today.